How do we see color? To first answer that, we have to know what color is. Color is the way we perceive light that bounces off objects. Most of the light on Earth comes from the sun, and sunlight is composed of all light frequencies and contains all the colors of light. The frequencies of light that we can see are from about 400 nanometers to 700 nanometers, and are known as the visible light spectrum. That is the distance between the crests of each wave of light, and every color of light has a different distance between its crests. These are also called the length of a period. These light waves are able to give an object color because it absorbs all frequencies of light except the one that gives it color. Take this pencil for example. It is yellow because there is white light hitting it, and then all wavelengths of light, except yellow, are being absorbed. We can specify that color to approximately 570 nanometers. So once this 570 nanometer light is reflected off the pencil, it travels into your eye and is received by photoreceptors. There are two kinds of photoreceptors, rods and cones. Cones are the ones which allow us to perceive color. These cones are found by the fovea centralis, which is a depression near the center of your retina. Of these cones, there are three different types of cones. Blue cones, which perceive short wavelengths of light, green cones, which perceive medium wavelengths of light, and red cones, which perceive long wavelengths of light. These cones work together to help us perceive color in the visible light spectrum. For example, this yellow pencil. The red receptor is being stimulated about 95%, and the green receptor is stimulated about 15%, which together sends to the brain the color yellow. Isn't that kind of weird? Because didn't you learn in kindergarten that green plus red is brown? Well, that may work for pigmentations, but the color you perceive is the stimulation of your three cones. It's not actually the colors that you would think they'd be. And this is very important for computer designers because it allows them to replicate the entire light spectrum with just three colors. They use blue, green, and red in different combinations and intensities to replicate all the colors of the visible light spectrum. Black can be created through the use of no lights, and white can be created by the full intensity of all three. Blue, green, and red are created by their single lights, respectively. Cyan can be created through green and blue, purple can be created through red and blue, and yellow is created through green and red. Other colors can then be created through different intensities and light combinations. Orange can be created through red and a little green, pink can be created through red and a little green and blue, and turquoise can be created through blue, green, and a little red. So I hope you found this video enlightening. So here's a picture of a rainbow. It's red, orange, yellow, green, blue, indigo, violet, right? Well, that's what you'd see when you look outside at your window and see one after a stormy day. But not if you're seeing this on your computer. So just to make it a little fair, I think I'd show you one that is a little more close to what your computer's actually showing you. Because you don't really see orange, yellow, purple, indigo, any of those colors. It's only what you think you see. So here's the colors that it actually is.